Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, I would like to present a topic on differential equations of second and higher order with the constant coefficients. In the previous videos, we have seen the differential equations of first order and first degree, and we have discussed several methods, and also we have seen the applications of first order and first degree differential equations, namely one is orthogonal trajectories and other one is Newton's law of cooling. Now the next topic is differential equations of second and higher order with constant coefficients. So what is the standard form of this equation? These equations, a differential equations is of the form dn y by dx power n plus p1 dn minus 1 y by dx power n minus 1 plus so on plus pn into y is equal to q of x, where p1, p2, so on, pn are all constants, and q of x is a function of x, is called a differential equations of second or higher order, nth order differential equation with the constant coefficients. In this, suppose if q of x not equal to 0, then the given equation 1 is said to be non-homogeneous linear differential equation with constant coefficients. Suppose if it is equal to 0 on the right hand side, then it is called a homogeneous linear differential equation with constant coefficients. So an equation is of the form, for example, d cubed y by dx cube plus 3 dy by dx plus some 2 into y is equal to cos x. So clearly it is a third order differential equation, and here the coefficients all are constants. 3 is a constant, 2 is a constant, and the right side is a pure function of x. Now we are going to see how to solve this type of equations. Now we follow the notation throughout the chapter here onwards. We use the notation d by dx is equal to d. Wherever you have d square x by dx square, d square by dx square, we use d square, and dn by dx power n is equal to d power n. Then the equation 1 can be expressed in the notation dny capital D power ny plus p1 d power n minus 1y plus p2 d power n minus 2y plus so on plus pn y is equal to q of x. Or on taking outside the variable y, you will get in this form d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on plus pn of y is equal to q of x. So clearly this is a pure function of d, where p1, p2, so on, pn are constants. So I can assume it is a function of d, it is f of d. So the equation 2 can be written as f of d of y is equal to q of x, where f of d is a polynomial in d of nth degree of nth order d power n plus p1 d power n minus 1 plus so on plus pn. So, and we call this is the operator form of the given differential equation. Here d is called the differential operator, which is denoted by d by dx. So the standard form is d power n y by dx power n plus p1 d power n minus 1 y by dx power n plus so on plus pn y is equal to q of x. This is the nth order differential equation with constant coefficients. So in operator form, the equation can be written as the equation 2 as d power n plus p1 d power n minus 1 plus so on plus pn of y is equal to q of x. Now I am considering the homogeneous linear differential equations, that is in the form f of d into y is equal to 0. What is f of d? D power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on plus pn of y is equal to 0. Or we can write the same thing as f of d of y is equal to 0. So I would like to find the solution of these type of equations. If the right hand side is 0, how to write the solution of this equation? How to write the general solution? So in this, to solve these equations, I'm going to write this equation first, auxiliary equation. Auxiliary means I want to write an auxiliary intermediate equation for f of d. It is in terms of m, that is m power n plus p1 m power n minus 1 plus so on plus pn is equal to 0. I would like to consider f of m, that is a function of m, that is obtained by replace m by d in the equation. So this equation having nth order, so this equation having n roots, m1, m2, m3, so on mn. Suppose if the equation is m square plus 2m plus 3, 0, and m will have 2 roots. If it is a 3-degree equation, that will have 3 roots. So because it is a nth degree polynomial and nth degree equation, right side 0 maybe, so it is nth degree equation, so it has n roots, m1, m2, m3, so on mn. So here we write the solution of the given equation based on the roots of the equation. So how you are writing, I will give details about the solution based on the roots of the equation. So suppose I am assuming only for 2 roots and I am expanding this for n case. Let a and b are 2 roots of the auxiliary equation f of m is equal to 0. If I assume f of m is equal to 0 is a quadratic equation, then it have only 2 roots a and b. Suppose if the case 1, what is the case 1? If the 2 roots a and b are real and distinct, if the 2 roots are like 2 and 3, then the complement, the solution, general solution of f of d into y is equal to 0. I am going to see that the solution of f of d into y is equal to 0. The solution will be in the form c1 e power 2x plus c2 e power 3x. That is the standard notation. If 2 and 3 are real roots, if m1 or a and b are 2 real roots, then the solution will be in the form y is equal to c1 e power ax plus c2 e power bx. And case 2, suppose if the roots are real and equal, that means what? If the roots a and b are same and which is equal to m, a and b are same, if the roots are 1 comma 1, the roots are real and equal. In this case, the solution will get in the form c1 plus c2x into e power mx. That is the general solution when the roots are real and equal. So you have to remember these forms directly. These are the ready-made things. So just you have to apply based on the roots of the equation. If real and distinct roots, then we write in this form. When the roots are real and equal, we write this form. When the roots are complex roots, that is in the form a plus r minus ib, then the solution will be in the form e power ax of a cos bx plus b sin bx. This is the standard form when the roots are complex roots of the form a plus r minus ib. The third case is when the roots are complex and repeated. Suppose if the roots are a plus r minus ib and it is repeated 2 times. The roots are repeated 2 times. Then what I have to write, the solution is e power ax into, because c1 plus c2x of cos 2x plus suppose 1 plus i2i. So the roots are like this. Then the solution is e power x into c1 plus c2x of cos 2x plus c3 plus 3 4x of sin 2x. This is the general solution when the roots are complex and repeated. So remember all the 4 forms, and while doing the problems, just you apply whatever you have case faced. First, if the case are real and distinct, then you write as first case solution. If the roots are real and equal, you can write the second case solution. If the roots are complex roots, then you go to the form y is equal to e power ax into a cos bx plus b sin bx. And the last one is if the roots are complex and repeated, we write the solution e power ax into c1 plus c2x of cos bx plus c3 plus c4x of sin bx. So this is the solution of the equation f of d of y is equal to 0, where the coefficients are constant coefficients. Now, I would like to do some examples based on this four models. So, solve the equation d square y by dx square minus 5 dy by dx plus 6y is equal to 0. So, clearly it is a second order differential equation. If you have the first order equation, then you have different methods already we have discussed. Because it's second, third, fourth, nth order. So these are all having same method. So if the equation is in this format, first write in operator form. So in operator form, we apply d by dx as a capital D and d square by dx square as capital D square, etc. So on writing in operator form, the equation will get in the form d square y minus 5 dy plus 6y is equal to 0. Or I can write d square minus 5d plus 6 of y is equal to 0. So this is f of d of y is equal to 0. Now to find the solution of this differential equation, we need to find the roots of the auxiliary equation. So what is auxiliary equation? F of m is equal to 0 is the auxiliary equation. So f of m is 0 obtained by replacing m by d in f of d. So the equation will be m square minus 5m plus 6 is equal to 0. So what are the roots of the equation? I'm writing in factor form. M square minus 3m minus 2m plus 6 is equal to 0. Or m into m minus 3 minus 2 of m minus 3 0. So the factors are m minus 2 of m minus 3 0. So m values are 2, 3. So the case comes under here you can observe that the roots are here you can observe that the roots are real and distinct roots. So you can show that in next slide. So the equation m square minus 5m plus 6 0. So I'm writing in factor form m minus 3 into m minus 2 is equal to 0. So the roots are 2, 3 are the roots of the equation. So when the roots are 2, 3, the roots are clearly here. The roots are real and distinct. So the solution will be in the form y is equal to c1 e power 2x plus c2 e power 3x. That is the solution of the given differential equation f of d of y is equal to 0. Now we see the another example. Solve the differential equation d square y by dx square plus 4 dy by dx plus 4y is equal to 0. So it is a second order differential equation. So by finding the roots of the auxiliary equation, you can write the solution. So before that, you have to write in operator form the given equation d square y by dx square plus 4 dy by dx plus 4y is equal to 0. So in operator form, I can write it is d square plus 4d plus 4 of y is equal to 0. Or this is f of d into y is equal to 0. So the auxiliary equation is f of m is equal to 0. That is m square plus 4m plus 4 is equal to 0. So I can write this as m plus 2 whole square. And expanding, you get m square plus 2ab 4m plus 2 square 4 is equal to 0. Or the factors are m plus 2 and m plus 2. M plus 2 repeated 2 times. So the roots are m minus 2 comma minus 2. That means what? The roots are real and equal. The roots are real and equal. So I'll go in the next step. The roots are real and equal. Therefore, the general solution will be in the form c1 plus c2x into e power minus 2x is the solution. Suppose if the roots are minus 2, minus 2, minus 2, then the solution will be c1 plus c2x plus c3x square also will add in the expression of e power minus 2x. If we add another root minus 2, then c1 plus c2x plus c3x square plus c4x cube of e power minus 2x. So in this way you can write the solution when the roots are repeated roots. So in the first example, we have seen when the roots are real and different or distinct, how to write the solution. When the roots are real and equal, how to write the solution, we have seen. So in the third example, I would like to solve this equation. D power 4. So already the given equation is in operator form. D power 4 minus 2D cube minus 3D square plus 4D plus 4 of y is equal to 0. So solve the equation by considering if 1 is the root of the equation, you satisfy whether the equation is satisfying or not. You take different roots and solve the equation. So here by the auxiliary equation is f of m is equal to 0. Here f of d into y, already the given equation is in operator form. F of d is, what is f of d? D power 4 minus 2d cube minus 3d square plus 4d plus 4. So now find the roots of the equation. So f of m is equal to 0. How will you get m power 4 minus 2m cube minus 3m square plus 4m plus 4 is equal to 0. So now check the roots of the equation. So m is 1. If I put 1 is not the root equation. If we put minus 1, what we will get? 1 minus 2 into minus 1 minus 3 into 1 minus 4 plus 4. Or this is minus 1 is the root of the equation. Clearly, you check it if you put m is equal to minus 1. Minus 1 whole power 4. Minus 1 whole power 4 plus 1. Minus 2 into minus 1 whole cube minus 1. Minus 3 into minus 1 whole square plus 1. Plus 4 into minus 1 minus 4 plus 4. Clearly, minus 4 plus 4 0. It is 1 plus 2. 3 minus 3, this is 0. Clearly, it is satisfying. So, m is equal to minus 1 is the root of the equation. So, m is equal to minus 1 root of the equation. I can write like this. 1 minus 2 minus 3 4 4. So, if I put minus 1, then minus 1, then minus 2 minus 1 minus 3, minus 3, minus 1 into minus 3 plus 3, this is 0, and minus 1 0 0 4, and minus 4, this is 0. So minus 1 is the root of the equation clearly. That means what I can write again, you can write what is the another root of the equation. If I put minus 1 again, 0 1 minus 1, it is minus 4, it is minus 4, and plus 4, 0 plus 4 4, and minus 4, this is 0. Again minus 1 is the repeated root. Minus 1 is repeated twice, and it is in the form m square minus 4m plus 4 is equal to 0. That means what? M minus 2 whole square is equal to 0. That means what? 2 comma 2 are the again roots of the equation. If we continue like this, then what we will get? 2 root, if it is 2 ones are 2, minus 2, minus 4, 0. Again I'm putting 0, 2 ones are 2, remainder 0. So the roots of the equations are minus 1, 2, 2. I hope this method is, you know very well, it is a synthetic division. So first write the coefficients, just I will explain. D power 4 coefficient 1, D cube coefficient minus 2, D square coefficient minus 3, and plus 4, plus 4. Initially put 0 here and use the random checkup whether this value is satisfying or not. So for minus 1 it is satisfying. That means what? Minus 1 satisfying means minus 1 is the root of the equation. Again minus 1 is satisfying. That means minus 1 is the other root also. Again 2 satisfies the equation. 2 is also the root of the equation. Again 2 is the root of the. There are 4 roots. So how we can write this equation? I can write the equation as m plus 1 whole square into m minus 2 whole square is equal to 0. So the roots are minus 1, 2, 2. So minus 1 repeated 2 times and 2 also repeated root. So the solution will be in the form C1 plus C2x of e power minus x. That is first 2 roots. This is the function for first roots, and remaining two roots. 2 is also repeated root. I am using C3 plus C4x of e power minus 2x. It is for the other two repeated roots 2 comma 2. So this will be the solution of the given equation. So just you need to know the synthetic division. You need to find the roots of the equation. Then only we can get the solution. After getting solution only, we can write the general solution of the given equation. Right? So I hope you are all understanding this. Now I will do another problem also. I worked out example. D square plus D plus 1 of y is equal to 0. Clearly this is in operator form. The original equation is d square y by dx square plus dy by dx plus y is equal to 0. This is the equation. So already the given problem in operator form, the given equation in operator form, just we need to find the solution, find the roots of the auxiliary equation. So how to write? This is here f of d. What is f of d? D square plus d plus 1. Now the auxiliary equation. What is the auxiliary equation? F of m is equal to 0. That means what? M square plus m plus 1 is equal to 0. So now our intention is to find the roots of the equation, and based on the roots of the equation we write the solution. So what is the equation here? F of m is equal to 0 is m square plus m plus 1 is equal to 0. Now I would like to find the roots minus b plus or minus root of b square, that is 1 minus 4ac by 2 into a. We know the formula, minus b plus or minus root of b square. B is 1, b square minus 4, a 1, c also 1. So minus 1 plus or minus root of 1 minus 4, that is minus 3 by 2. Or I can write the same thing as 1 plus or minus root 3 I by 2. So what are the roots? 1 by 2 plus or minus I into root 3 by 2. So it is in the form a plus or minus ib. The roots are 1 by 2 plus or minus I root 3 by 2. So these are in the form a plus or minus ib. Clearly the roots are, the nature of the roots are complex roots. The nature of the roots are complex roots. It is in the form e power a plus or minus ib. So we know that from case number 4, if the roots are complex in the form a plus ib, then the solution will be in the form e power ax of a cos bx plus b sin bx. So that is the standard format. I will show you here the solution. So that is case number 3. When the roots are complex roots of the form a plus or minus ib, then the solution will be in the form y is equal to e power ax into a cos bx plus b sin bx. That is the solution when the roots are complex roots. So in the repeated roots, it comes under case number 2. So now the roots are complex roots, and a is 1 by 2 and b is root 3 by 2. Then what is the solution will be? Y is equal to e power ax. Ax means a is 1 by 2, so that is x by 2 of a cos bx. A cos bx. What is cos bx? Cos bx means cos root 3 by 2x plus b sin bx. So, or you can put, if you have any doubt, you can put C1, C2 also. If A and B are repeatingly e power x. So, I can write the solution. These two are the constants. Don't come for A and B. A and B are different constants. These two are arbitrary constants. Y is equal to e power ax into C1 cos bx plus C2 sin bx. Don't confuse with the constants. So here a and b are e power x by 2. A is 1 by 2. So C1 arbitrary constant. Bx means root 3 by 2x plus C2 sin bx, and that means root 3 by 2x. So that is the general solution of the given differential equation of second order. So in this way, you can find the solution of the equation of the form f of d of y is equal to 0. So with these few examples, I conclude my this presentation. And in the next video, I will do how to solve the equations of the form f of d of y is equal to q of x, where q of x is a function of x. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.